Next is externally driven superchargers. We also call them turbo superchargers. An external type supercharger compresses air and through an oil cooler delivers it to the carburetor fuel air control unit intake where it is mixed with the fuel. Now this air which is compressed by the compressor is routed through the air cooler so that the temperature of the compressed air is lowered, since after compression the temperature of the air will increase. So in order to lower the temperature, the air is routed through the air cooler. Now an external type supercharger is composed of three main parts: compressor assembly, turbine wheel assembly and a full floating shaft bearing assembly. So the energy of engine exhaust gases directed against a bucket wheel or turbine provides power to drive the external supercharger. The turbine drives an impeller that compresses the incoming air. Now this external type supercharger has got three main parts. One is the compressor assembly. You can see in this picture, this is your compressor assembly. Second is your turbine wheel assembly. This is your turbine wheel assembly here, and a full floating shaft bearing assembly, and this is a full floating shaft. So three main parts: compressor, turbine and a shaft. Now the energy of the engine exhaust gases. So this turbocharger is basically using the energy of the exhaust gases against a bucket wheel or turbine. This turbine extracts energy from the exhaust gases. Now in this figure you can see this is this inlet, this is the inlet through which exhaust gases are coming in. These exhaust gases are directed against this turbine wheel. The turbine wheel will extract the energy of the exhaust gases, and this turbine will drive the compressor. This compressor, the compressor is here, this turbine will drive the compressor, since the turbine and the compressor are on the same shaft, and it is extracting energy from the exhaust gases to drive the turbine wheel, which drives the compressor, since the turbine and the compressor are on the same shaft. It is called turbo supercharger or turbocharger depending on whether it supercharges the air or merely maintains sea level pressure. Now in case if it is supercharging the air, then it is called turbo supercharger, or if it is merely maintaining the sea level pressure, then in that case it is called turbocharger. However, the supercharger is required to boost the manifold pressure above 30 inches of mercury. So in case if it is a supercharger, then it is required to boost the manifold pressure above 30 inches of mercury. Now this is called a multi-speed supercharger because the speed of this compressor is dependent on the speed of the turbine, because they are on the same shaft, and the speed of the turbine is dependent on the quantity and pressure of the exhaust gases directed against the turbine. So because of that reason, this is called a multi-speed supercharger. The volume of exhaust directed through the turbine is determined by the position of the wastegate, and the wastegate is operated by a control in the cockpit. Now the volume of exhaust gases which is directed against this turbine is controlled by the position of a wastegate. We will see what is a wastegate. There is a valve kind of thing which is called a wastegate, and this is operated from a control in the cockpit. So the position of the wastegate will determine the quantity of exhaust gases being directed towards the turbine wheel. The compressor assembly consists of impeller, diffuser and casing. Now this compressor which is used to compress the air has got three main parts: impeller, diffuser and casing. The air for the induction system enters in the center of the compressor. Now the air which is to be compressed enters the center of the compressor. You see, this is your compressor and this is your compressor inlet. Now air which is to be compressed, it goes through this opening. There is an opening on this side, and the air which is to be compressed enters the compressor through this opening. You can see here this is a blue arrow which is showing compressor inlet. So This is compressor inlet, and after compression the air is coming out through this outlet. The air for the induction system enters in the center of the compressor casing through a circular opening. Here it is picked up by the blades of the impeller, giving it high velocity as it travels outward towards the diffuser. Now, the air which is entering the compressor is picked up by the impeller blades. These impeller blades will give it high velocity and it travels towards the diffuser. As the air leaves the impeller, the diffuser vanes direct the airflow and convert the high velocity of air to high pressure. Now, impeller has picked up the air, it has given it high velocity, and the air from the impeller is directed towards the diffuser. Now, this diffuser vanes will direct the airflow and will convert high velocity of air to high pressure air. The turbocharger is basically an arrangement of a turbine and a compressor on a common shaft. So, we have seen it earlier that the turbocharger, it is an arrangement of a compressor and turbine. This is compressor, this is turbine on the same shaft, on the common shaft. The turbine assembly consists of a wastegate valve which regulates the amount of exhaust gases directed to the turbine. So, in our last slide we have read that the turbine assembly also has a wastegate valve which will regulate the amount of exhaust gases being directed to the turbine, and thereby it will regulate the speed of the rotor, turbine and impeller. So, rotor is your turbine and impeller, since both are on the same shaft, they are rotating. So, this wastegate valve is regulating the speed of the rotor. If the wastegate is completely closed, all the exhaust gases are forced through the turbine wheel. If the wastegate is partially closed, so corresponding amount of exhaust gas is directed to the turbine. So, and if the wastegate is fully opened, nearly all of the exhaust gases pass overboard, providing little or no boost. So, in general, the wastegate, if it is completely closed, so in that case all the exhaust gases will be directed, will be forced to go through the turbine wheel. In case if it is partially closed, wastegate is partially closed, then corresponding amount of exhaust gas is directed to the turbine. The directed exhaust gases strike the turbine blades. Yes, we have seen in our earlier slide also, the directed exhaust gases, they strike the turbine blades and cause the rotor to rotate, the turbine and the impeller. The gases are then exhausted overboard after most of their energy is extracted. So, after the turbine has extracted the energy of the exhaust gases, that air is sent overboard and the turbine blades are rotating. The degree of wastegate closing determines the amount of air pressure boost obtained from the turbocharger. So, the amount of boost which is obtained from the turbocharger depends on the degree of wastegate opening or closing. We have discussed this earlier also, like after compression the temperature of the air increases and too high carburetor air temperature is not desirable, as it may cause detonation in the cylinders. So, we will read in our next chapters what is detonation, but it is not a desirable characteristic. So, high temperature of air in the carburetor will result in detonation in the cylinders. So, in order to avoid that, the compressed air is passed through the air coolers. In the figure you can see there are, this turbocharger unit is split. You can see this is your compressor housing, this is your compressor impeller here, this is your center housing, this is turbine and this is your turbine housing. Then again this is your shaft where it is to be lubricated, and this complete thing is your turbocharger assembly. Now, normalizer turbocharger. What is a normalizer turbocharger? The normalizing turbocharger is externally driven, powered by the energy of exhaust gases. Now, this is also powered by the energy of exhaust gases and it is externally driven. These systems are not designed to boost manifold pressure above 30 inches of mercury, rather they only compensate for the power lost due to the pressure drop resulting from increased altitude. As we know that as we go up, we fly high, your pressure drops resulting in engine power loss. So, in order to compensate for that power loss, we need a system which can boost the manifold pressure. The normalizer turbocharger system, this will not boost the manifold pressure above 30 inches of mercury, but it will only compensate for whatever power has been lost due to pressure drop from increased altitude. So it will just try to maintain your sea level pressure. They are designed to be operated only above a certain altitude. So these normalizer turbochargers, you cannot operate them right from the ground or from the sea level, but they can be operated only above a certain altitude, since maximum power without normalizing is available below that altitude. Now coming to ground boosted turbocharger system. What is a ground boosted turbocharger system? We have just seen a normalizer turbocharger where it was just trying to maintain the sea level pressure. It was not boosting the manifold pressure above 30 inches of mercury. But in case if we want to have a system which can supercharge with to more than 30 inches of mercury, in that case it will be a turbo supercharger system, and they are called ground boosted turbo supercharger system. Turbo supercharged systems are designed to operate from sea level up to their critical altitude and are called ground boosted sea level turbocharger system, and are called ground boosted or sea level turbo supercharger system. Now what is a critical altitude? Critical altitude is defined as the altitude above which a particular engine supercharger combination will no longer deliver full power. Engines equipped with turbo supercharger system develop more power at sea level than engines without turbo supercharging. These engines are also called sea level boosted engines. In a turbo supercharger air induction system, the ram air enters the system through an inlet on the side of the nacelle. Now you can see the figure here. This is your side of the engine, side of the nacelle or side of the cowling, and your ram air is coming through this inlet. You can see these yellow arrows. Now your air is coming through this thing, through the inlet opening. Now after coming through this inlet, the air passes through a filter. You can see here, this is your filter, and after filter you get a filtered air, ram filtered air you are getting. This ram filtered air passes through the turbo supercharger. See, this ram filtered air is passing through the turbo supercharger. After passing through the turbo supercharger, the air gets compressed. The air, you can see this compressed air is going to the carburetor or the fuel injector. From the fuel injector or the carburetor, the air, you can see here, is routed to different cylinders. The air is routed to different cylinders. In case if the induction air filter becomes clogged, then alternate air or heated engine compartment air enters the induction system by compressor suction through an alternate air door within the nacelle. We have read about this in our earlier slides about the alternate air door. So again, this is being repeated again, like in case if the filter gets clogged, the air comes through the alternate air door within the nacelle. The alternate air door can be operated automatically or it can be operated manually. We have read about this earlier. The turbocharger is controlled by the wastegate and the wastegate actuator. Now here you can see in the figure, this is your turbocharger. On the turbocharger you have a wastegate. This is your wastegate. See, this is your wastegate and this is your wastegate actuator. So the wastegate will regulate the quantity, the amount of exhaust gas being driven to the turbine. So the turbocharger is controlled by the wastegate and the wastegate actuator. The position of the wastegate butterfly valve is controlled by the wastegate actuator. Now this wastegate valve, this position, its position is controlled by this actuator, wastegate actuator. The wastegate actuator is connected to the wastegate butterfly valve by mechanical linkage. So both the actuator and the valve, they are connected to each other by mechanical linkage, and the wastegate actuator will control the position of the wastegate butterfly valve. So wastegate will bypass the engine exhaust gas around the turbocharger turbine inlet. The speed of the compressor and the amount of intake boost is controlled by controlling the amount of exhaust gases that pass through the turbine of the turbocharger. Now, since the amount of exhaust gas which is passing through the turbine is controlled by the position of the wastegate valve, this is controlling the speed of the compressor and finally the amount of boost being created by the turbocharger. Now, engine oil from the engine oil system is used to lubricate the turbocharger. Now, since you have the rotating parts in the turbocharger, it needs lubrication. So, that lubricating oil is from the engine oil system. Engine oil is also used to cool and lubricate the bearings that support the compressor and turbine in the turbocharger. So, lubrication is one requirement, and the engine oil will also cool and lubricate the bearings that support the compressor and the turbine in the turbocharger. The oil inlet line to the turbocharger is from the oil cooler. Rather, I will say that the oil inlet line from the turbocharger is from the oil pump, and oil return line from the turbocharger is to the oil scavenge pump. Now, this turbocharger, this will have two lines, oil inlet line and one oil outlet line. The oil inlet line, in the oil inlet line which is coming to the turbocharger is from the oil pump. From the oil pump, it is being routed through the oil cooler and comes to the turbocharger. The oil which is going out of the turbocharger is going to the scavenge pump, to the oil scavenge pump, and finally from the scavenge pump it is sent back to the oil tank. We have read in the lubrication chapter the purpose of the scavenge pump. There is also one-way check valve in the oil supply line which prevents oil from draining into the turbocharger while the engine is not operating. So, at the time when your engine is not operating, this check valve will prevent oil from draining into the turbocharger. So, oil seals on the compressor turbine wheel shaft will prevent the lubricating oil from entering the turbine and the compressor housing. The oil pressure in the wastegate actuator controls the position of the wastegate. We have seen that there is a wastegate actuator and there is a wastegate valve, butterfly valve. The wastegate actuator controls the position of the wastegate butterfly valve. But how does it control? Now, the oil pressure is coming to the wastegate actuator which controls the position of the wastegate. There are controllers which provide the correct pressure in the wastegate actuator. Now, the oil which is coming to the wastegate actuator, that pressure is controlled by the controllers. These controllers, they will either restrict the oil flow or allow the oil to return to the engine. So, now two cases, in case if oil is restricted, more oil is restricted, then there will be more pressure in the wastegate actuator. So, if the controller restricts more oil, then there will be more pressure and due to the more pressure in the wastegate actuator, the wastegate will close more. More closing of the wastegate causes more exhaust gases to pass through the turbine, which results in increasing the speed of the compressor and then finally raising the inlet pressure, or you get more boost. Another case, in case if oil is not restricted, then reverse will happen and you will have reduced boost pressure. So, the controllers, they are restricting the oil flow or they are not restricting the oil flow to the actuator, which finally controls the position of the wastegate. Another example of ground booster turbo supercharger system or a sea level booster turbo supercharger system, the following components regulate the system automatically. So, in this system, there is an automatic control. You have exhaust bypass valve assembly, then you have a density controller and you have a differential pressure controller. So let us see the figure. You have this engine exhaust gases. These engine exhaust gases, they are coming to the turbine, to the turbocharger, and from the turbocharger these gases, rather these compressed gases, they go to your cylinder intake. So you see here, air is being compressed, this exhaust gas has entered the turbocharger. From the turbocharger it goes to the cylinder intake after compression. Now constant power output is maintained if the wastegate position at fully open and closed and between these two extremes is regulated. Now in case if the position of the wastegate is regulated at the extreme positions, that is the full open position or the full closed position, and also in between these two positions, these two extreme positions, in case if we are able to regulate the position of the wastegate, in that case we will be getting a constant power output from the system. If the wastegate is completely closed, all the exhaust gases are forced through the turbine wheel and maximum supercharging is achieved. So we have seen this earlier. In case if the wastegate is completely closed, then we get more exhaust gases through the turbine wheel and we get maximum supercharging. If the wastegate is fully open, nearly all the exhaust gases pass overboard, providing little or no boost. If the wastegate is partially closed, a corresponding amount of exhaust gas is directed to the turbine and constant power output is achieved below the maximum altitude at which the system is designed to operate. Now in case if the wastegate is partially closed, that is it is in between the two extreme positions, in that case that corresponding amount of exhaust gas is directed to the turbine and we get constant power output below the maximum altitude for which the system is designed to operate. In order to maintain the pre-selected manifold pressure setting, the wastegate is almost fully open at sea level and continues to move towards the closed position as the aircraft climbs. Now when we are at the sea level, your wastegate is almost fully open, and as the aircraft starts climbing, in that case your wastegate starts moving to the closed position as the aircraft climbs. So we have seen in our earlier slides that the engine oil pressure is controlling the position of the wastegate valve. The engine oil pressure, which is acting on a piston in the wastegate assembly, controls the position of the wastegate valve. Engine output power increases when oil pressure is increased on the piston, causing the wastegate valve to move towards the closed position. So we have seen this earlier. Your output power, your engine output power will increase when your oil pressure is increased. Engine output power will decrease when your oil pressure is decreased on the piston, causing the wastegate valve to move towards the open position. Now the oil pressure, how is the oil pressure controlled? The engine oil pressure is controlled by the oil which is bled back to the engine crankcase. Now the oil which is bled back to the engine crankcase, that will control the engine oil pressure applied to the top of piston attached to the wastegate valve. So this oil which is bled back to the engine crankcase will control the engine oil pressure which is applied to the wastegate valve. The quantity of oil returned to the engine crankcase is controlled by two independent control devices. One is your density controller and another is your differential pressure controller. So here in the figure you can see you have a density controller, this is your density controller, and here you have a differential pressure controller. So these two units, they will regulate the bleed oil. So in the figure you can see here you have the engine oil pressure inlet, your engine oil is coming here from this side, it is going to the wastegate actuator. So this is here, it is your engine oil. From this line your engine oil is returning back, this engine oil is returning back to the crankcase. This is your crankcase area here. So engine oil is returning back to the crankcase. Now the quantity of engine oil which is bled back to the crankcase is controlled by the two controllers. One is your density controller and another is your differential pressure controller. And the oil which is bled back to the crankcase, this controls the engine oil pressure being applied to the top of the piston attached to the wastegate valve. So basically the oil which is being bled to the crankcase controls the oil pressure acting on the piston of the wastegate valve, and this return oil is controlled by two controllers. One is the density controller and another is your differential pressure controller. The density controller regulates bleed oil only at the full throttle position. So this density controller, this regulates the bleed oil only at the full throttle position. Inside the density controller are dry nitrogen filled pressure and temperature sensing bellows. So inside the density controller you have bellows which are filled with dry nitrogen. These are pressure and temperature sensing bellows, and these bellows react to pressure and temperature changes between the fuel injector inlet and the turbocharger compressor. The bellows maintain a constant density by allowing the pressure to increase as the temperature increases. So as the temperature increases, it will cause the pressure to increase and will maintain the constant density. Now due to the movement of the bellows inside the density controller, the bleed valve repositions it and it causes the bleed oil quantity to change, which changes the oil pressure on top of the wastegate piston. The differential pressure controller functions during all positions of the wastegate valve other than the full open position. So this density controller, this is operating only at full throttle position, whereas your differential pressure controller operates at all positions except the full throttle position where your density controller is operating. The density controller and differential pressure controller operate independently to control turbocharger operation at all positions of the throttle. So these two controllers, they are operating independently at all positions of the throttle. So this was about an automatically controlled turbocharger system. Although the internal functioning of this system was beyond the scope of this course, but just to give a brief idea, we have discussed about the controllers, the density controllers, the inside mechanism of the density controller. So we have seen what is the turbocharger, what is the supercharger, what is the purpose of these turbochargers. Now there may be problems, there may be snags we may encounter in the system. So let us see what are the troubles, what are the common troubles encountered in this system. First problem may be that the aircraft fails to reach critical altitude. We have seen what is the critical altitude. So let us see, in case if you encounter a problem that your aircraft is not reaching the critical altitude, then what may be the probable reasons. So another probable cause, wastegate is not closing fully and malfunctioning of controller. So we will see in the below columns that what will be the rectification action for that. So in case you have trouble that aircraft is not reaching your critical altitude, we have seen the probable causes: damaged compressor or turbine wheel, you have to replace the turbocharger; exhaust system leaks, you have to repair the leaks; and faulty turbocharger bearings, you have to replace the turbocharger. Now where your wastegate is not closing fully, in that case what will be the probable cause? Wastegate bypass valve bearing is tight, that may be the reason. Oil inlet orifice blocked, your oil which is inlet orifice is blocked. Differential controller malfunction and broken wastegate linkage. So wastegate is not fully closing, there may be several reasons. Now let us see one by one. your wastegate bypass valve bearing is tight, nothing can be done, we just have to replace the bypass valve. So oil inlet orifice blocked, in that case you have to clean the orifice. Broken wastegate linkage. Now in case if the linkage is broken, then we have to replace the linkage and adjust the wastegate for proper opening and closing. Then now in case if the differential controller is malfunctioning, then we have several reasons. Seals leaking, in that case you have to replace the controller. Diaphragm broken, you have to replace the controller, and controller valve stuck, in that case also you have to replace the controller. So in case if you have encountered a problem where aircraft is not reaching your critical altitude and the reason is that your controller is malfunctioning, in that case you have to replace the controller. Then another problem that might be encountered is engine surges. Then again there are several reasons. One is bootstrapping, and then you may have wastegate malfunction and you may have controller malfunction. So in case of bootstrapping, you ensure that the engine is being operated in the proper range. So we have to ensure that engine is operating in the proper range. In case of controller malfunction, we have seen that we have to replace the controller. In case of wastegate malfunctioning, we have seen the several reasons and the rectification actions. Another is density controller malfunctioning. Again, there may be several reasons: seals leaking, bellows damaged, valve stuck. In all the cases, we just have to replace the controller. So in most of the cases, in case if your wastegate is malfunctioning, your controllers are malfunctioning, we just have to replace the controllers. And the wastegate malfunctioning, we can either check the linkage. In case if the linkage is broken, we can repair it, we can adjust the opening and closing of the wastegate. Now what are the different inspections and maintenance on the induction system? So let us see, there are a few inspections which are done on the induction system. The induction system should be checked for the following during all regularly scheduled engine inspections. So during all inspections, following should be checked: cracks and leaks. There might be cracks and leaks in various parts of the induction system. There might be leaks, so we need to verify that there are no cracks, no leaks during the inspections. Security of mounting of all the units of the system. So all the units of the system, they should be secured properly, they should be mounted properly. Cleanliness at all times. So this is very important. The induction system should be cleaned at all times. We need to be very careful about the filter, the induction air filter, and it should be cleaned regularly. So any obstruction in the system, again there should be no obstruction in the system. Replacement and cleaning of air filters. So air filters, they are to be cleaned regularly and they are replaced after a fixed interval of time. So clean air filters are also very important. Alternate air doors and transition ducts. We need to verify that the alternate air doors are free to move, there is no obstruction, there is no breakage, and all the ducts, they are leak proof, they are mounted properly. On the turbocharger unit, we need to verify secured mounting, we need to verify leakage, and we need to see the linkage is not broken. The linkage between the wastegate valve and the wastegate actuator is not broken. The wastegate valve is free to move and it is also to be lubricated at fixed intervals. Then wastegate free movement and lubrication. So these are some of the points which we verify during our inspections, some of the maintenance actions which we perform on the induction system. Now there are a few problems which may encounter in our induction system. We have seen the problems what we encounter in the turbocharger. Now these are the problems which we encounter in the induction system. The first problem, you may see that your engine fails to start. Now in case if the engine is not starting, what may be the probable causes. Your induction system might be obstructed. Number 2, there might be air leaks in the system. Now, in case if your induction system is obstructed, so we need to check your air scoop and the air ducts. In case if there is any obstruction, we need to remove it. That will be the corrective action. In case there are air leaks, the air leaks might be at the carburetor mounting and intake pipes. So we need to check the carburetor mountings and also the intake pipes. So small amount of air leakage will also not start the engine. So in case if there are leakages, you have to tighten the carburetor and repair or replace the intake pipe. Second problem might be engine is running rough. In case if your engine is running rough, there might be several reasons. It may be loose air ducts, maybe leaking intake pipes, your engine valves is sticking, bent or worn valve push rods. So several reasons. Let us see one by one. Loose air ducts. In case if the ducts are loose, if the air ducts are loose, then we need to inspect these ducts and tighten them. Leaking intake pipes. Now in case if your pipes or intake pipes are leaking, then we need to check the intake pipe packing nuts and tighten them. So basically in case if they might be loose, we need to tighten them. Engine valves is sticking. Now in case if the engine valves are sticking, then we need to remove the rocker arm cover and check the valve action. The corrective action will be to lubricate and free the sticking valves. Bent or worn valve push rods. In case if the valve push rods are bent or worn, then we need to inspect them and replace the worn or damaged push rods. Another problem might be low power. In case if we are seeing low power, then the causes may be restricted intake duct. Second might be broken door in carburetor air valve and dirty air filter. So in case if the reason is restricted intake duct, we need to examine the intake duct and remove any restriction. If the reason is broken door in carburetor air valve, in that case we need to first inspect the air valve and replace it in case if we find it defective. If your air filter is dirty, we need to inspect as the case may be. So we may clean the air filter, or in case if required we can also replace the air filter. Another problem that we may face is engine idles improperly. There are several reasons. One is shrunken intake packing, another is hole in intake pipe, or another reason might be loose carburetor mounting. So in case if your intake packing is shrunk, in that case we need to inspect that packing for proper fit and replace if it is defective. Now if there is a hole in the intake pipe, we need to first inspect the intake pipe and replace in case if it is found defective. Carburetor mounting is loose. In that case we just need to tighten the mounting bolts. First we need to check whether it is loose, the bolts are loose. In case if they are found loose, we have to tighten them. So we have seen about the induction system, we have seen about the naturally aspirated engines, we have seen about the supercharged engines, we have read about the turbochargers, we have read about the problems being encountered in the induction system and what are the inspection and maintenance required in the induction system. Thank you.